All right, let's talk about empirical formulas and molecular formulas. So empirical formula is basically the lowest ratio of the atoms in the compound, where molecular formula is different. But let's look at number 5 on that paper, and I'm going to do them on here. So a compound is 85.7% carbon and 14.3% hydrogen by mass. Determine its empirical formula. So you assume that you have 100 grams, and we need to get the moles of each of these. So 85.7 grams, right? If I have 100, 85.7 of them are carbon. And my molecular mass of carbon, 12.01 grams in 1 mole, right? This is my carbon. My hydrogen, 14.3 grams and 1 grams in 1 mole of hydrogen. All right, let me grab my calculator. So we want to do these calculations to figure out how many moles of each. Oop, that calculator's dead. Hang on. Okay, so 85.7, and watch right now, I really have 3 sig figs, don't I? So 85.7 divided by 12.01. Really probably doesn't matter in this case, but let's just go with it. So 7.14 moles of carbon, right? Over here, 14.3 divided by 1.01 equals 14. I'll use it, 2, moles hydrogen. So what you do is you divide them both by the lowest number you have here. Look at this. Because right now you would have it, you're trying to get integers, right? So 7.14 divided by 7.14 gives you 1 for C, and then this would give you 2 for H, right? So it's C1H2, which you don't have to write the 1, so it's CH2, okay? Let's do the next one. We'll see if we get the same answer as the teacher. So number 6 says, 12.7% aluminum, 19.7% nitrogen, and 67.6% oxygen. All right, assume 100 grams. So now I'll have 12.7 grams of aluminum. I'm going to look at my periodic table. Oh, where's aluminum? There it is. I'm going to put 26.98 grams in 1 mole. All right, and then I have 19.7 grams nitrogen, and that's 14.01 grams in 1 mole, and 67.6 grams of oxygen, which is 16 grams in 1 mole. So 12.7 divided by 26.98, 0.47, 19.7 divided by 14.01, 1.4 or so, right? 67.6 divided by 16. 4.2, let's just say. So divide these all by the lowest and see if we get to integers. All right, let's see what we get. This takes us to 1. This is going to be approximately, it's going to be close to 3. Whoops, 0.47. Yeah, this is really close to 3, 2.9787. And then 4.2 divided by 0.47. This one's really close to 9. Really close to 9. So it should be aluminum 1, nitrogen 3, oxygen 9. I think that looks like a 9 on your sheet there. All right, let's look at the next one. 7 says, and you can stop this at any time to look at the work and try to absorb it. I just want to get this done in the 15 minutes of the video that I have here. So it says 43.7% phosphorus and then the rest oxygen. So I'm just subtracting from 100%. That means I have 56.3% oxygen. All right, we're going to assume 100 grams, right? So 43.7 grams. Phosphorus, look at there, it's 30.97 grams in 1 mole, right? 56.3 grams. And notice I keep doing T-charts. I feel it's very important to keep doing the T-charts so you understand how to line up the units, right? So they cancel and you're left with the one you want. Cancel and you're left with the one you want. Okay? So 43.7, oops, divided by 30.97. All right, so this is about 1.41. 56.3 divided by 16. Okay, is about 3.5. So we're going to divide like this. See what we come out with. This gives us 1. And then 3.5 divided by 1.41. Actually, look at this. We're about 2.5. So now I look at these and I say, you know what do I have to multiply these by to get an integer? And I have to multiply both of them. Well, if I multiply by 2, this will give me 5 for the oxygen and 2 for the phosphorus, right? P2O5. All right, let's look at number 8. So 39.6% carbon, 7.7% hydrogen, the rest oxygen. So I'm adding 39.6 plus 7.7, and I'm going to subtract that from 100. 52.7%. Assume 100 grams. 39.6 grams of carbon. Carbon is 12.01 grams in 1 mole, right? 7.7 grams hydrogen, 1.01 grams in 1 mole, and 52.7 grams oxygen. Getting down low here, sorry. 16 grams in 1 mole. All right, let's figure out what we got here. 39.6 divided by 20. All right. We're about 3.3. 7.7 divided by 1.01. All right, we're about, wow, 7.6. 52.7 divided by 16. Oh, actually, we're close to 3.3 here, aren't we? So we're going to divide all these by 3.3. And we'll get 1 and 1. Whoops. 7.6 divided by 3.3. Okay, we're coming at about 2.3. I think what we want to do, 2.3. All right, so if we look at these and decide what can I multiply to get integers, if I take 2.3 times 3, that gets me very close to the integer. So I'm going to multiply these by 3. So I'll have 3 carbon and 3 oxygen, and I'm at 6.9, so 7 hydrogen. So carbon 3, hydrogen 7, oxygen 3. Now, the thing about molecular formula is they have to give you the molar mass. So we just came up with in problem, oh, he's doing problem 5. So problem 5 had CH2 as our empirical, right? I believe he's spelling it wrong on his sheet, darn him. All right, which if we look at the mass of this, it would be 12 and then 2.02, and our molar mass would be 14.03. If this was the molecular formula, but they're telling us it's 84. So we say we divide it by 14.03 or so, right? 84 divided by, we'll just do by 14. Gives us 6. That means we multiply this by 6 to get the molecular formula. So you end up with C6H12. So empirical is the lowest ratio. Molecular formula is what the molecule actually looks like, actually reacts like, actually acts like. So in this case, empirical was CH2, but the molecular, how it actually looks as a molecule, is C6H12. All right, so take a look at this and see if these make sense to you, and we will talk. Thanks.